Hello all, I am Dr. Rizvi and this is part 4 of our video on manufacturing process. In this video, we will discuss metal forming process. So let us start with metal forming. Metal forming is basically a process in which the metal is deformed or the material is deformed plastically and it acquires the shape of the geometry of the die. In this, tools such as dies and punches are used, and many other tools are also used depending upon the type of process. When the material is subjected to external load, basically it deforms into three categories. It may deform plastically, elastically, or it may fracture. When the material deforms elastically, it will return back to its original shape, and this will happen when the load is removed. When it do not return back to its original shape, then it is termed as plastic deformation. And when the deformation causes the separation of the part from the body, it is known as fracture. Now we will classify metal forming processes, and it is basically classified into two types. First one is bulk deformation and the second one is on the basis of sheet metal work. The bulk deformation processes are of four types. They are rolling, extrusion, forging and wire drawing, while the sheet metal work are bending, deep drawing, shearing and stretching. Before starting metal forming, we will first discuss recrystallization. Recrystallization is basically the process of deforming the old grains and replacing them by new grains, and the growth is until the original grains have been entirely consumed by the new grains. In this process, the strength and hardness of the material is reduced, but eventually it increases the ductility of the material. The temperature at which the recrystallization in the material occurs is known as recrystallization temperature, and it differs for pure metal and for alloy. For pure metal, it is around 0.3 to 0.4 times the melting temperature of the pure metals, and for alloys it is 0.5 times the melting temperature. Here you can see the recrystallization temperature of four metals. For example, iron is there. Iron's melting point is 1539 degree and its recrystallization temperature is 462, which is near about 0.3 to 0.4 times of its melting point. These are the stages of recrystallization. First image is showing the deformed state of the grains. On heating, the grains start to recover, and on partial recrystallization, the grain boundaries are shown like this. When these grains are fully recrystallized, the grain take proper grain boundaries and they are well aligned. And on further heating, the grain start to grow. Now we'll discuss hot working and cold working processes. They are dependent upon the recrystallization temperature. When we are working on some material above recrystallization temperature to deform its shape, then it is termed as hot working. And when we are performing deformation below recrystallization temperature, it is termed as cold working process. In hot working, the grain refinement occurs due to recrystallization. As we are working above recrystallization temperature, the newer grains will form and grain refinement will occur. But in the case of cold working, no grain refinement is observed. In hot working, the hardening is eliminated due to recrystallization, whereas in cold working, hardening is not eliminated. If there are cracks in the material due to hot working, newer grains are formed and all the previously existing cracks are welded up. But in the case of cold working, as we are working below recrystallization and no newer grains are formed, so crack propagation are more and the chances of cracks occurrence is more. Finally, scaling is observed when we are working above recrystallization temperature. These scaling are due to oxidization of the upper layer of the material and they causes poor surface finish in hot working. But in cold working, no scaling is there, so the surface finish obtained is good. The first process here in metal forming is rolling. In rolling process, the metal is being forced between these two wheels or rolls and force is applied. This process is done to reduce the size or the thickness of the sheet. We can take an example of aluminum foil that we use to pack our foods. It is made from rolling process. The thin sheets are made from rolling process. Here you can see an industrial example of rolling process. This GIF shows the rolling process. Initially, we have inserted a thick material into the rolls and now from the other side, its dimension is reduced and we are getting a thinner sheet through rolling process. Next process is forging process. Forging process is basically uh, the metal is kept between the dies and it is forged to acquire the shape of the die. You can see in the next slide how the metal is forged between the die. It is a red hot material heated above recrystallization temperature and so these scalings have been formed on the surface of the metal. When we force the dies against this material, it will take the shape of the die. In the next slide, you will see the process of forging. The dies are forcing the material between them and the material is taking the shape of the die. Next process is extrusion. Extrusion is the process when we push the work or the metal through the ram into the die and it acquires the shape of the die and deforms accordingly. This is the die, this is the ram. When we force the metal through the die, it will take the shape of the die. Here is the die hole and it will take the shape of the die. Here you can see an industrial example of extrusion. This is the ram, this is the red hot material and this is the die. When it is forced through the die, it will acquire the shape of the die. Here you can see the GIF showing the forcing of metal through the die. This is the red hot material, this is the ram and when we force it will acquire the shape of the die in form of a rod. It is coming out. Next process is bending. Bending is basically done in sheet metals to bend the sheet into required angle. Here is an industrial example of bending. This is the punch, this is the die and this is the sheet which we are bending. This GIF shows the bending operation of the sheet. The sheet is kept over the die and the punch is coming from above and forcing it to acquire the shape of the die and to bend it. Next operation is deep drawing. These operations are generally performed to produce cup shapes, cylinders, etc. The punch is forced and the sheet acquires the shape of the die. We can form these type of shapes, cup or tub shapes from deep drawing. Here is a GIF showing the process of deep drawing. Next process is shearing. Shearing is basically tearing off the material from the parent material. And here you can see the die, this is the punch and this sheet is being sheared off and cut into two halves as and when required. This is the industrial application. These are the punch, this is the die and when this will come over the sheet, it will cut it from here. In the GIF, you can see precisely the operation of shearing. This is the full sheet and this is punch coming downwards, forcing the sheet and removing the extra material that is not required in the product. That's all for the video. Subscribe our channel on YouTube, Dr. Rizvi channel. Thank you.